Hello everyone, let's solve the problem sort an array. Given an array of integer nums, sort the array in ascending order and return it. You must solve the problem without using any built-in functions in big of n log n time complexity and with the smallest space complexity possible. Okay. This problem is totally based upon sorting algorithms, okay, which totally comes under the fundamentals, right? So let's see the topic tags: sorting, heap, priority queue, merge sort, bucket sort, radix sort, and counting sort. Okay. If we talk about the complexities of these various mentioned sorting algorithms, if we use a heap, we will have a time complexity of n log n. Okay. If we do a merge sort, we will have a time complexity of n log n. Okay. If we use bucket sort, we are going to have a n plus k time complexity. Okay. Similarly, for radix sort as well as counting sort, we are going to have a time complexity of O big O of n plus k. There are numerous other sorting algorithms, right? We have another popular sorting algorithm called quick sort. Okay. But in worst case, it takes a time complexity of big O of n square. Okay. So as we have been said to write an algorithm with time complexity of big O of n log n, so we will see this one, the priority queue method, merge sort, and as a bonus we will see, let's say we will see a counting sort algorithm. All right, let's see our approach using a priority queue. Let's say we are given this set of numbers. Okay, a priority queue implements something called a heap. Okay, and in Java, a priority queue by default implements a min heap. Okay, which means the minimum element at the top. Okay, a heap is internally a binary tree in which the topmost element is the smallest element. Say we have 1, 2 and 3. This 1 will be here, this 2 will be here, this 3 will be here, something like this. The main thing is that whenever we access the topmost element in a min heap, we will get the minimum element or the minimum number among the set of numbers that we have provided to the heap. So let's just assume that our min heap keeps our set of numbers in ascending order. Okay, so what will be the ascending order? 1, 2, 3, 4, 5 and 6. There is also one more thing called max heap. It keeps the maximum element at the top. Okay, now what we will do, we will keep a pointer at the beginning of our nums. Okay, and one by one we will pop the topmost element. Okay, 1 goes here, then I comes here, pop the topmost. 2, pop, it comes here, move up, pop. So like this our nums will be altered, and then we will return our nums. Okay, so let's see its code. So this is the code for our priority queue approach. We initialize a priority queue and then iterate over our given array nums, and we insert all the elements from nums to our priority queue, and it will internally sort our elements. Okay, then we initialize a index variable, say I. Then we will one by one pop the topmost element from our priority queue, and at each step we will put them serially into our nums array only. Okay, then we will return nums. The time complexity of this solution is big O of n log n. Okay, log n has been taken by our priority queue to internally sort our elements. Okay, and this log n task is performed n times because we are putting our element n times, n elements. Okay, and then we one by one pop our elements from the top and we put it in our nums. That is also another n log n because we are popping n times, and popping from the topmost position takes another log n time complexity. So our time complexity is n log n, and our space complexity is a big O of n because we are using this priority queue which stores n elements. Okay, now let us look at our merge sort algorithm. What do we do in that? We partition our array into halves as long as we can. Okay, let us make a partition here. We get 7, 6, 5 and 4. This we have from this we have 3, 2 and 1. We will partition them further. We partition them here. We will have 7 and 6. We will have 5 and 4. Okay, from this we will have a 3 and 2, and this one is a single one, so let's keep it as it is. Okay, now when we have partitioned all of them into a single chunks, okay, we will merge them. We'll merge them in a sorted fashion. So if we merge 7 and 6, we will have 6 and 7. If we merge 5 and 4, we will have 4 and 5. So from this we will return them 6 and 7. This will return 4 and 5. Okay, this will return 2 and 3. All right, Now I have made it more clear. Okay, we have 6 7 and 4 5. We will merge them. How will we merge them? We'll merge them in a sorted fashion. So what will be the sorted fashion of this 6 7 4 and 5? It will be 4 5 6 and 7. For this, what will be the sorted order? 1 2 and 3. We will return this and we will return this. All these things are happening recursively. Okay, we will recursively break them into two halves. Okay, and then we will return the sorted orders. Okay, so finally we have 4 5 6 7, and here we have 1 2 and 3. Okay, how will we merge them? We will merge them in a sorted order. So what will be the sorted order? It will be 1 2 3 4 5 6 and 7. Okay, now let's write the code for our merge sort algorithm. Let's call our method merge sort. On nums, we will initially have two pointers at the start and at the end of our array. Okay, that is 0 and nums dot length. What are we doing? We have put a pointer here, another pointer here. Okay, we want to sort our array in this range from 0 to one position before our end. Okay, okay, return nums. We pass in the array. We have our start index and our end index. Okay, why we are keeping a start and end index? Because initially we start from here and end to here, then we will make a partition. Our start will be this will be our start, our end will be this, right? For this part, our start will be this and our end will be this, right? So that's why we are using two pointers, okay, to define our range, whom to sort, okay, or on whom to call our merge sort. Okay, now if our end minus start is equals to 1, return. What does that mean? When we completely partition our array into single elements, right? When 7 6 5 4, this will be start and this will be end, the next position, right? This will be start and this will be end, right? So the difference of between end minus start will be 1, and that's when we know that we have reached our base condition, right? That we are now at single element level. Okay, and at that case we will return. Otherwise we will calculate our position for the partition. Okay, start plus n by 2, or you can do a start plus n minus start by 2. Okay, now we will call our merge sort on both sides of our partition. ARR start to whom? Mid. Start to mid, and on ARR mid to end. Okay, say this is our start, this is our end, and say this is our mid. We called our merge sort on this part and mid to end on this part. Okay, okay, now they will recursively break our array down into single elements. After we are done, what are we supposed to do? We are supposed to merge them, right? So we will merge start, mid, and end. Okay, why also mid? Why are we passing mid here? We will see. Let's write our merge function. Takes the array start, mid, and end. Okay, we will create a array. Let's call it merged new int. What will be the size? It will be end minus start. Why end minus start? Just see. Say our end is here. Say our end is here and our start is here. Okay, we want to merge the area between these. Okay, just don't see the elements. I'm just telling you what will be the size of the array. It will be end minus start, right? Isn't it? That's why we are creating an array of size end minus start. Okay, this merged array will store the elements in sorted order, right? After merging, right? We had this 7 6 5 4. After merging them, they became 6 7 4 and 5. Then they are further supposed to be merged, right? So this merge sequence will be stored in merged array. Okay, okay, int I equals to s, j equals to mid, and k equals to 0. What is that? See, let's say we have this sequence 1 4 6 2 3 7. We put two pointers here, I j, that is start. Okay, say this one is start and this one is mid. Okay, So for iterating purpose, we are initializing I and j. Okay, we'll start from start and j will start from mid, and we will have another merged array, right? 1 2 3 4 5 6. This will be k for iteration. Okay, 1 is less than 2, yes, put 1, move I here. 4 is less than 2, no, 2 is less than 4, right? Put 2. Okay, j moves here. 4 and 3, who is smaller? 3 is smaller, put 3, move up j. 4 and 7, who is smaller? 4 is smaller. Okay, move I. 6 and 7, who is smaller? 6 is smaller, move I. Okay, exhausted, right? Whichever, whatever is remaining, right? This one is remaining, say we had, say, more 7 8 9 10, we will simply put all of them serially here. Okay, 7 8 9 10. Okay, this one is another lead code question called merge sorted array, right? I suggest you check that problem out as well. Okay, so we will do this here. Okay, while I is less than mid and j is less than end. Okay, what we will do, if array of I is less than array of j, what we will do, in our merged array in k, we will put the smaller one, array of I. Otherwise, if array of j1 is smaller, okay, so in merged at that index k, we'll put array of j. Okay, and at each step we will increment our pointers. Okay, I have made this part shorter by using ternary operators. Now what are we supposed to do? One of the array would be exhausted and iteration on one another array would remain, right? So we will do that. Okay, whichever numbers are yet to put, we will put them one by one at the end of merged. Okay, let's say our first array was yet to be exhausted, so we will exhaust it. Merged of k plus plus equals to array of I plus plus. Or our second array was yet to be exhausted, j less than end, merged of k plus plus equals to array of j plus plus. Okay, either one of these while loops will run, not both, because one would be exhausted and other would still remain, right? So only one would be executed. Now what, we have merged our array and our merged array is sorted. Okay, now we have to put that elements, sorted elements, into our original array, right? So let's do that. For int, let's say idx, it starts from 0, 0th position of merged, idx less than merged dot length idx plus plus. Put array of s plus idx, start plus idx equals to merged of idx. Okay, what does that mean? Let's say we have 7 6 5 and 4 3 2 and 1. So this part is sorted. Okay, in our merge, this is start, this is end, 1 2 3 and 4. Let's say this is idx I. Okay, I is initially 0, start plus 0 is this position, we will put 1 here. I moves here, it becomes 1, start plus 1 is this position, put 2 here. Okay, I moves here, this one is 2, start plus 2 is this position, put 3 here. Okay, I comes here, I becomes 3, start plus 3 is this position, put 4 here. Okay, that's what we are doing, updated our original array. Okay, all right. Other than this, instead of doing this, we can do something called system.arrayCopy in Java. It takes the source array, that is from merged we are going to copy. From where we are going to copy? From the 0th index of merged, right? Where to copy? We are going to copy to array arr. From where to where in array? Start and end minus start. Okay, what is end minus start? The number of elements or the length of the sequence that we are going to copy. Okay, let's try to run it. Submit. Okay, that works. What is the time and space complexity? The time complexity of a merge sort algorithm at worst case is big O of n log n. Okay, remember this thing. And space complexity is a big O of n. Why big O of n? We are creating this merged array, right? For this we are assigning an extra space, so big O of n. Okay, now let us look at our third approach, that is using count sort. Okay, What do we do in count sort? Say we are given these numbers 1, 3, 4, 6, 2, 5. Okay. What we will do? We will count their frequencies. Okay. We will have an array 0, 1, 2, 3, 4, 5, 6. We will have an array and we will store their frequencies. The frequency of 1 is 1, frequency of 3 is 1, frequency of 4 is 1, frequency of 6 is 1, frequency of 2 is 1, frequency of 5 is 1. Okay, let's say we have some more numbers. Let's say a 2 again, 6, 3. Okay, in that case the frequency is 2, 6 frequency is 2, 3's frequency is also 2. Now what does this mean? This means that this 1 has occurred one time, 2 has occurred two times, 3 has occurred two times, 4 one time, 5 one time, and 6 two times. That is, the indices our elements in our given array. Okay. Now what we will do? Go through this array and print the index as many times as its frequency. So what do I mean by that? We will iterate. For 0 the frequency is 0, for 1 the frequency is 1, print 1 one time, for 2 the frequency is 2, two times, for 3 it's two times again, print 2 times, for 4 it's one time, 5 has occurred one time, 6 has occurred two times. So this is our sorted array. It's very simple. Okay, we are basically creating a map sort of a thing, right, in which we map the frequency to the index, right? Okay, but in our question we have negative numbers as well, but we can't have negative index, right? So in that case we will directly use a hash map. Okay, and we will store each of the numbers frequency, and what we will do, we will have the minimum number from the array, okay, that is say 1, and the maximum number from the array, that is 6. And what we will do, we will run a loop from this minimum to the maximum and print each of the numbers as many times its frequency. Okay, let's have the example 2 minus 1 minus 2 3 minus 1 4 and 5. Okay, if we create a map we get minus 1 two times, minus 2 one time, then 2 one time, 3 one time, 4 one time, and 5 one time. Now what is the minimum? It's minus 1. What is the maximum? It's 5. We will run a loop from minus 1 to 5. Okay, we are at minus 1. How many times has minus 1 occurred? 2 times. Print minus 1 2 times. Okay, we come at 0. Is 0 in this array, in the map? No, skip. Similarly we don't have 1 as well, right? Then we come to 2, print 2 one time, right, one time, then 3 one time, then 4 one time, then 5 one time. Okay, that's what we are doing in counting sort. Now let's quickly write the code for this approach. Okay, we are supposed to have a map. Integer means the element in nums, and another integer which is the frequency. Map equals to new hash map. Let's say our min is what are the constraints? Nums of I can be, okay, this, let's take 5. Okay, and max equals to 0. We can take integer dot max value as well, but it's the same, right? We are taking the max value possible for our problem, given problem. Okay, for int n in nums. Okay, map dot put what? Put the number 1 plus map dot get or default n comma 0. Okay, just the basic way of updating our hash map, right, with its frequency. Okay, let's check for our maximum element at dot max and n. Similarly for our min min min. Okay, now we have our max and min. Now we are supposed to iterate from min to max and put the elements serially into our nums array. Okay, let's see how. Let's take an index variable. Okay, for int, let's say n, let's say num equals to min, starts from min, then num less than equals to max, right? This is our range. Num plus plus while what? Map dot get or default what? Num comma 0. Okay, greater than 0. As long as our frequency is not 0, we will keep adding that number to our answer array, right? Or nums of idx equals to num. Okay, idx plus plus. As we update our nums in a particular index, we move to the very next index right away, right? Okay, and what we will do, we will decrease the frequency. We will decrease the frequency. How? Num comma, let's use this, -1, sorry, -1. Okay, at the end return nums. Let's try to run it. Let's submit. There we go. The time complexity of this approach is big O of n to iterate over nums, and a big O of k, let's say, to iterate from this range from minimum to maximum. We assume that range is k. Okay, and our space complexity is big O of n. At max our number of unique elements is n only. Okay, let's assume that our space complexity is big O of n. Let's once print the hash map. Okay, system.out.println to see what is exactly contained in the hash map. See, 1 has occurred one time, 2 has occurred one time, 3 has occurred one time, and 5 has occurred one time. See, 0 occurred 2 times, 1 occurred 2 times, 2 occurred 1 time, 5 occurred 1 time, right? So this is pretty much about this approach. All right, and last but not the least, we have our built-in arrays.sort nums. But as the question mentioned, we are not supposed to use that, right? Though it is a big of n log n time complexity work, okay, but we can't use it, right? Internally it uses a sorting algorithm called timsort, which are basically hybrid sorting algorithms. They use quick sort as well as insertion sort together. Okay, so the main thing is we can't use this. If we could use this, then this wouldn't be a question, right? One day I saw a post on LinkedIn that a guy posted it as an achievement, that he solved this sort and array question using just in one line. Okay, that's not an achievement. You can't do this, right? When we have this question, we have to write the whole algorithm ourselves, right? Otherwise it's not supposed to be a question. Also, it's a medium one, right? So that's the thing. If you like this video, do hit the like button, share this video, and subscribe to my channel if you haven't, and I will see you in the next video. Bye bye.